Hi, welcome to Miss Gola's Geometry Notes. This is the first set of notes that is going to lead off this chapter. It should be your point notes. It's a stapled copy with naming points, lines, and planes on the back side. At any point in any of these videos, you're more than welcome to stop the video and try the problems on the back on your own, but follow along while we do the notes, okay? The first basic geometry term is a point. A point is a location. It has no size or shape. We use a capital letter to name a point. So we're going to draw a point here. And let's just name it point A. So we have to name it with a capital letter. And just to name a point, we just say point A. A line is made up of points. So any 2 points form a line. A line has no thickness or width. And to name a point, we name it by any 2 points that are on the line or the lowercase script letter. So let's draw a line. And lines go in both directions forever and ever. We have point X and we have point Y. And we're going to name line N. So we can name this line by the 2 points that fall on it. So line XY. We can name it by line N, the lowercase script letter. Or if we want to shorthand it, we put the 2 points that we named, X, Y, and these arrows above it, which indicates it's a line. Now we're going to talk about collinear points and non-collinear points. Collinear, if you think of this start to the word that says co, the prefix of it, it means together. So together on a line, they're points that are on the same line. So for example here, X and Y are on the same line. Non-collinear points are points that are not on the same line, so they're not together. Points that do not fall on the same line, but there must be at least 3. So if we drew another point here, let's name it point Z, you can say X and Z are non-collinear. Line segment. A line segment is a part of a line. It has 2 endpoints. And when we name a segment, we name it by its endpoints. So if we have a line segment here, there's going to be dots at the end because it's a part. It doesn't go on after these points. And let's name it A, B. Oh, I missed a word here. I'm sorry. By the 2 endpoints. So we can name this line segment AB, or we can simply just name it AB, and there's no arrows at the end here, so that means it stops. Okay, flip it over. Okay, a ray is a line with a start point but no end point. It goes on forever. A ray with two endpoints and a ray over both letters. So that's how we name it. We name a ray with 2 endpoints and a ray over both letters. And the endpoint must come first. So let's draw a ray here. Let's name QP. So we name this, our endpoint's going to come first, and P is going to be in the direction. So it honestly looks like if you drew your ray here, your Q would be your start point and your P would go on forever. Opposite rays are rays that share an endpoint. So an example, here's a ray, and this is an opposite ray, so they share the same endpoint. Okay. A plane is a flat surface made up of points. Any 3 points make a plane, and a plane extends infinitely in all directions, so it keeps going on forever. Name a plane by 3 non-collinear points on it or the uppercase script letter. So let's draw a square here. So that's the easiest way to draw a plane. And let's just put 3 points there. Let's name it M and an O. and we're going to name it plane P. So that's like a cursive P. So we can call this plane P or plane MNO. It does not matter the order in which these points go. So you could have named it ONM, OMN, doesn't matter. Okay. So non-collinear points are points that are on the same line, so they're the same definition as collinear. So we can say two coplanar points are M and N. And non-coplanar points, there's points that do not fall in the same plane, but there must be at least 4. So say if this was below the plane and we name this plane X, we can say M and X are non-coplanar. Okay. Now the last set of notes for today are intersections of lines and planes. So two lines intersect at a point. So if we draw 2 lines here, they touch at a point. And 2 planes intersect at a line. Now drawing intersecting planes are a little bit tricky, so we're going to try our best. So let's draw a plane this way, and then coming up from that plane, we have this plane, and it goes bottom of it. So this dotted line here, that's where those 2 planes like intersect. So it's at a line. Okay, hope that helped. I'm going to do the problems here. Using the diagram to the right, name the following. Name 4 collinear points. This line only has 3. This line only has 3. So the only line that has 4 is this line. So we have H, N, K, I. A line that contains point M. So here we have a line. Let's name it line. Ooh, throw my pencil. Line P. So I just used the lowercase script letter. A line that contains point H and K. So where's H and K? They both fall on line R, but I want to name it line NI. Another name for line Q. Let's say line JK. You could have used KL or JL. It doesn't matter. And you could have easily named it as KJ. So any order or the reverse order will work. Intersection of lines, we know it should be a point because there's 2 lines. So P and R, it is point N. Use the diagram to the right to name the following. A line containing point F. So where's point F? It is line J. Another name for line K. Well, here's line K. Name it by 2 points. So I'm going to say line BE. A plane containing point A. So you need 3 non-collinear points to name a plane, or you could do this uppercase script letter. So let's do plane M. An example of 3 non-collinear points. So we need 3 points that do not fall on the same line. So you can pick any of them that fall on not the same line. So let's pick one from line K. So let's say B. Let's pick one from J, but not E, because E is on the same line as B. So let's say D and A. Just because you're non-collinear does not mean that you have to be on the same plane as well. So we named 3 non-collinear points that were all on different planes. Okay. The intersection of plane M and line K. So if we think of a line going through a plane, it only touches at one point, and that's point E. 3 coplanar points. We want 3 points that are on the same line of this prism. So let's say ZVW. They're kind of on that sidewall of that prism. A plane containing point X. So we can say plane R. Intersection of plane R and plane ZVY. So we need a line by the notes. So R is like the ground here, and ZVY is that backside. So it would be line segment VY. How many planes appear in the picture? So we have 1, 2, 3, 4 for that up of the prism, but then we only have 1 on the bottom, so we have a total of 5. How many planes contain point W? So we have to think this side plane, and the bottom, so that's 3. Intersections of line L and M. So line L is going through these 2 planes and line M is on this plane, so it is point E because 2 lines intersect at a point. Another name for line Q, plane Q. So to name a plane, we need to name a plane by 3 non-collinear points. So if we name 2 points from this line, so let's say it's FE and I. Points D and E, are they collinear or are they coplanar? So D and E, they both look like they're on this line L, so they're collinear. And how many times do plane P and Q touch? So this is like a trick question. If you think about this in real life, this is like the front wall of my classroom, and this is like the window wall, so they don't touch at all. So they actually have no intersection. Okay, hope you enjoyed the notes.